Hey everyone, it's Justin again. In this lesson, we're going to take what we learned last time about parallel and perpendicular slopes and use it to help write equations of lines in the coordinate plane. By the end of this lesson, you should be able to write the equation of a line that is parallel or perpendicular to a given line. First, we'll review information needed to write equations of lines. Next, we'll review finding slope from equations of lines. And finally, we'll complete 2 practice problems. You've just spent some time reviewing the 3 different ways to write equations of lines: slope-intercept form, point-slope form, and standard form. Think for a moment. If you want to write the equation of a line, what information do you need? Did you come up with slope? This one's a little tricky because we can get the slope in a few different ways. Sometimes you can just be directly given a slope. Other times, you might have to calculate the slope. What do you need to be able to calculate the slope? Yep, 2 points. Aside from the slope, you also need a point. It can be a special point like the y-intercept, but any old point will do as long as it's somewhere on the line. That's all from Algebra 1, right? I bet you're thinking, Justin, where's the geometry here? Well, you see, in the last lesson we learned about parallel and perpendicular lines, and they have a very special relationship in their slopes. That's right. We have a new way to find slope that we can add to this list. If I give you one line and ask you to find a new line that is parallel or perpendicular to it, that's another way that I can tell you what the slope of your new line should be. Let's do some review together quick. Here are 3 equations of lines. One's in slope-intercept form, one's in point-slope form, and there's one in standard form. Take a moment now to manipulate these equations to find each of their slopes. Slope-intercept form and point-slope form make finding the slope easy, because it's right there in the equation. In our slope-intercept equation, we can see negative 2/3 right here as the coefficient to x. Similarly, in our point-slope equation, we can see the slope of negative 3 outside the parentheses on the side of the equation with x. Standard form is a little trickier. In the end, you should have gotten an answer of 5/2. Go ahead and check your manipulation work against mine. I was aiming to isolate y, which would give me slope-intercept form, since I know that's an easy way to identify my slope. I started by subtracting 5x from both sides, and then divided all of my terms on both sides by negative 2. From here, I can see the 5/2 as the coefficient to x, but we can also go one step further to swap those 2 terms on the right side so it's officially in slope-intercept form. Here's our first full example problem. Find the equation of the line that is perpendicular to 2x minus 3y equals 3 and goes through the point 3, negative 2. Remember, we need 2 pieces of information to be able to find the equation of a line: a point and a slope. Here's the point. They give us that outright, but where's the slope in here? Here's the slope. By giving us a perpendicular line, this problem says, hey, just take the opposite reciprocal of this slope. So go ahead and find the slope of 2x minus 3y equals 3. Did you get 2/3 as your slope for the original line? If not, go back and double check your work. Okay, so we have the point 3, negative 2, and the slope is 2/3. Hold on. 2/3 is the slope of this line. We want the slope that is perpendicular to this. So what slope should we use to write our equation? Negative 3/2. since perpendicular lines have opposite reciprocal slopes. Whew, that was a close one. Now that we have a point and a slope, we can write our final equation. Before jumping right in, let's think about the best way to do this. We have three options: point-slope form, slope-intercept form, and standard form. Now, standard form we can eliminate right away. The only time that will be the simplest form is in certain word problems and real-world applications. Of the other two, what information do you need to write an equation in point-slope form? You need a slope and any point on the line. What information do you need to write an equation in slope-intercept form? Here, you need a slope and specifically the y-intercept. Let's look back up here. We have the point 3, -2 and a slope of -2/3. Which form do you think will make it easier for us to write this equation? Point-slope form or slope-intercept form? Yeah, point-slope form. Our point is not the y-intercept because it's not on the y-axis. You could use our point to substitute into slope-intercept form and solve for b. But why do all that work? We could just take our information and pop it right into point-slope form without the extra steps. Go ahead and put the point and the slope into point-slope form. Does your answer look like mine? Unless the question specifies that you have to use a specific form, you could write your equation any way you want. I will always show you the way that makes things as simple as possible. If you choose to go a different route, that's totally okay. You can always manipulate your equation, or mine, to make sure that they're equivalent, even if they look different. Let's do one more example together before you practice on your own. Find the equation of a line that goes through point 0, 7 and is parallel to the line y equals -2x. Go ahead and try this one out on your own. I'm sure you found your point right away. That's 0, 7. The slope is going to come from here. The slope of y equals -2x is -2. Hold on, let me double check this time. Find the equation of a line that goes through. It is parallel. Okay, there. Parallel lines have the same slope, so I'm also going to use a slope of -2. Now I have my point and my slope. Did you notice that this point is the y-intercept? Since the x-coordinate is 0, that tells us this point will be on the y-axis, making it a y-intercept. That means the simplest way to write this equation will be slope-intercept form. If you didn't quite catch that and your equation is in a different form, you can always manipulate either one of our equations to make sure that they're equivalent. Now you can use parallel and perpendicular relationships to write equations. This skill is going to come in handy in our next lesson. See you then.